Section 1.6 is on functions of operations, including adding, subtracting, multiplying, dividing them, as well as composing them. So let's take a look at the basic operations of functions, and then we'll take a look at composition of functions. So if we have two functions, f of x and g of x, remember, those are the two most common names, but it could be h of x, w of x, it doesn't really matter. But if we have two functions, then when you see this notation of f plus g of x, it literally just means to take function f and add it with function g. Combine your like terms and simplify. Same thing, when we are subtracting, we're going to take f of x and then subtract g of x. Just remember here, make sure to distribute that negative to everything of that second function, and then go ahead and combine your like terms. When you see fg of x, this is multiplication. So this is saying take function f of x and multiply it with g of x, whether that means to FOIL it, use the distributive method, etc. But it simply means multiply the two functions together. And then when we have f over g of x, we're dividing them. So take function f of x and divide it by g of x. Okay? Try to reduce that by maybe factoring and canceling out like factors so that it's simplified as possible. Now, once you perform these operations, oftentimes it'll ask you to find the domain. So just remember, the two big things to watch for are fractions, because denominators cannot be 0, and then radicals, because they must be positive inside. So let's take a look at a couple examples. I'll do one of them out completely with you and start another. So in this first scenario, we have our functions, f of x and g of x, and question 1 says f times g of x. So we're literally going to take function f, which is x squared plus 3x minus 4, and multiply it with function g. Now remember, multiplication is commutative, so if you want to rearrange the order of them, feel free to do so. But I'll just multiply now. So I'm going to distribute the x squared to both terms. This gives me x to the third minus x squared. Now distribute the 3x to both terms. This gives me plus 3x squared minus 3x. And then distribute the negative 4, so minus 4x plus 4. Take your time to double check your calculations, because if one of those terms is off, obviously then the whole thing gets thrown off. So again, x to the third, negative x squared, 3x squared, minus 3x, negative 4x, and positive 4. Now combine those like terms. So we have x to the third plus 2x squared minus 7x plus 4. So there is the product of those two functions. Now it says find the domain. Well, do I see any square roots or fractions? No. So what this means is there won't be any of those sort of errors to watch for. So our domain can be any number that we want, aka from negative infinity to positive infinity, otherwise known as all real numbers. Okay, so for number 2, let's look at number 2. This one says f plus g, and then there's a negative 3. Please understand that this does not mean multiply by 3. Negative 3. What this means is add the two functions and then evaluate with negative 3. Okay, so if I'm to do that out, we will actually add those together. So we'll have function f plus function g. Put the like terms together, x squared plus 4x minus 5. And now evaluate with negative 3. So where I see those x's, I now plug in a negative 3. This will give me 9 minus 12 minus 5. Make sure to go in order. So 9 minus 12 is negative 3. Negative 3 minus 5 is negative 8. This time around, you do not need to find the domain because we're not left in terms of x, right? We're actually evaluating, so no domain needed. Okay, what I want you to try is number 3. So we're dividing. See if you can simplify once you have that fraction set up, and then because it is a fraction, you do have to watch for domain. So try that one on your own. Okay, so besides adding, subtracting, multiplying, and dividing, we can also compose functions together. So there's 2 notations for this that I'm going to underline, and they mean the same thing. But we read those as f of g of x. So sometimes you'll see a little open circle. That is not a multiplication symbol. It's an open circle, or the functions will just be back to back. These 2 underlined pieces mean the exact same thing. Now, what do they actually mean? It means to take the second function that's listed there, so in this case, g, take that function and plug it in for f. Okay, so notice below here what I am going to underline in orange. Notice this statement is not true, are not equal, because one of them is saying take g and plug it in for f. That's what the first one says. And the second one says take f and plug it in for g. Okay, so the blue underlined mean the same thing, but the orange are not equivalent. So let's do an example nice and slow so that you can understand this. If I ask you to find f of g of x, again, it's saying take function g and plug it in for f. So we're literally going to take function g, and wherever I see an x and f, I'm going to plug that in. So f of g of x in this case means the following: f of x minus 7, right? G of x is x minus 7, so instead of a g of x, I put x minus 7. So that'll be 2, function f is 2 times that quantity of g plus 1. Okay, if there was x's multiple times, then plug that x minus 7 in wherever I see an x. Now simply distribute. And there's my solution. Okay. So I'm going to start a couple of these for you and have you finish them. So for number 4, this one's saying g of f of x. Remember, this is also the same thing. I just want to make sure everybody's clear with that. That is the same notation. So different worksheets and different books use different notations, and these mean the same thing. But what it's saying is it's saying take f and plug it in for g. So I'm going to take function f, which is 3x minus 4, and plug it in wherever I see an x for g. So in this problem, it'll look like that. Let's do that out. So we have g of 3x minus 4 will equal 3x minus 4 all squared plus 3. So you go ahead and actually simplify that and come up with an answer. Now, number 5 is very similar, but notice here it's not in terms of x, it's in terms of actually evaluating. So you have 2 options. You can ignore that -2 and find f of g of x first, get your answer, and then plug in -2, or even easier, start by finding g of -2. So if I find g of -2, it means to plug in -2 in for x for g. So g was x squared plus 3, so that'll be -2 squared plus 3. This will give me 4 plus 3, which is 7. Now it's saying take that 7 and plug it in for f. So now I'm going to find f of 7. F of 7 is to do 3 times 7 minus 4. This gives me 21 minus 4, which is 17. And there's your final answer. Okay, try number 6, h of g of x. The last thing we're going to look at is a function that's given to us, and we want to come up with 2 separate functions that could create it. So it says find 2 functions, f of x and g of x, so that when I compose them together, it creates h of x. Make life as simple as possible, okay? So for example, I see this quantity right here of x minus 5. So I'm going to call that my g of x, because remember, we're doing f of g of x, so g of x is what's inside first. So I'm going to call g of x minus 5. If that's the case, then when I go find f of g of x, it's saying I'm going to take x minus 5 and plug it into wherever I saw an x. So that means that f of x, instead of an x minus 5, would have just been x squared plus 9. Let me show you how that makes sense, and then I'll repeat it again. So now think about this. If I said f of g of x, it would be saying f of x minus 5. So it would be saying take x minus 5 and plug it in where I see an x. So let's do that. If I plug that right on in, I would have x minus 5 all squared plus 9. And woohoo, that is the same thing of h of x. So again, what did I do? I looked at sort of a quantity, and I see that x minus 5, and I know when I'm doing a composition, it's saying substitute that quantity in for x. So if x minus 5 was my quantity, then where I saw that, I replaced it with just a simple x. See if you can come up with something for 8. Now, you can have different options for these. I'm just trying to make it be as most basic as possible. So try 8 and see if you can come up with two functions that when you compose them together, you get 4 over 2x plus 7.